Hello, Algebra 1 students. This is section 4 of chapter 1, the distributive property. The distributive property should be a review from last year, but let's see what it looks like. Since we don't know what A, B, or C stands for in this problem, we cannot combine B and C. So the distributive property says we can distribute A among the two numbers inside the parentheses. So A times B. Distributed, by the way, that was me, like a paper boy distributes the paper. A distributed times B, you can put a dot for now if you'd like, plus A times C, and that's the distributive property. It also works if it was a subtraction problem. So we'll change colors. Let's distribute our A times B minus, and then distribute the A times C. So the negative sign or the minus sign stays in the middle. Sometimes it's written in the opposite order. I guess I could leave it green, where you have the B plus C first and the A at the end. It still is distributed, but you're distributing it backwards. Maybe you went down the block and then you're coming back the other direction. A is still being multiplied times B, plus A is still being multiplied times C. Multiplication is commutative, so if you said B times A, that's okay. And if you said C times A, we would end up with the same answer. So that's just a couple of examples of what the distributive property looks like. How could we use the distributive property to solve the following problems mentally? In other words, we don't have a calculator with us. We're trying to do mental math. So, for example, 1a, multiplying 5 times 210, isn't something I do in my head quick. So I'm breaking up 210 as 200 plus 10 times 5. Because I can mentally do 5 times 200 fairly quickly, and of course 5 times 10, and that'll give us 1,000 plus 50. So our final answer is 1,050. So see how much easier that is than to try to multiply 5 times 210. The same thing happens here. 44 times 2 is not that big of a deal. And then taking half of 44 is very simple. So now if we say 44 times 2 plus half of 44, or 44 times 1/2, we'll get 88 plus 22, which will give us 110 for our final answer. So that's just a few ways you can use the distributive property backwards to undo a problem and make it a little bit easier. Example 2 says to rewrite each expression using the distributive property, then simplify. So first they want us to distribute 12 times y, and I'm not going to put the dot because we're trying to get out of the habit of that. 12 times 3, and then it says simplify. Well, 12 times y, I cannot get any more simplified than that, and 12 times 3 is 36. These are not like terms. I cannot add those, so I'm finished here. For B, I distribute my 4 to everything in parentheses. 4 times y squared plus 4 times 8y plus 4 times 2. Notice how I'm using parentheses since everything was in parentheses. So that gives me 4y squared plus 32y plus 8. And since there are no like terms, that is in simplest form. Watch out for the negative for this next problem. We have a negative 4 that we're going to distribute. So it's going to be a negative 4. I'm going to go ahead and put it in parentheses, times a negative 8 minus, and this is this minus sign right here. What's being distributed? Negative 4 times 3m. So the 3m, I left it as a positive 3m, and I took care of my negative sign here. This is the negative sign, the operation in the middle. Just like I brought down the plus sign here, you're bringing down your minus sign. And a negative times a negative is positive 32, minus negative times positive leaves us with a negative 12m. And two negatives make a positive, and this is review from last year, so we get plus 12m. And again, they're not like terms, and so that is as far as I can go. coming from behind, negative 3 is now being distributed. Negative 3 times 2 minus, again, just copying that sign. What am I distributing? Negative 3 times what? Now it's times 5 cubed, and my negative sign came from the operation in the parentheses. I get negative 6 minus negative 15q, and minus a negative becomes plus 50. And that is our final answer. All right, so I've said several times, I've said the words like terms. To be like terms means that they have the same variable. Terms that have the same variable. Okay, and if they happen to have an exponent like we had here in this problem, the same variable, and they have to also have with the same power, with the same exponent. So y and y squared are not like terms. They both are y, but this one was a y squared and the other one is just y. So like terms are terms that have the same variable with the same power. Okay? If we're going to put something in simplest form, there can, it's when there are no other like terms that can be added. So when it's in simplest form, like we have, let's look at this example, there are no other like terms, so there's no like terms, or parentheses. In other words, you've taken care of distributing everything and you've simplified the parentheses as far as they can go. So that's when something is in simplest form, when there's no more parentheses and there are no more like terms to add together or subtract. All right, let's work on simplifying. For 4a, are these like terms? They both have a. A is to a power of 1, so those are alike. You can undo the distributive property. Some people like to do this and say, well, that's 17 plus 21 with the a outside, and 17 plus 21 is 38a. So that's showing using the distributive property. For b, if I wanted to use the distributive property, the like terms here are b squared. So I can take out the b squared, and that's 12 minus 8 plus 6b. So I can take care of saying 12 minus 8, and that's 4. Now the proper way to write this is to always put your coefficient in front. That's a word that we haven't talked about yet, but it's coming up at the bottom of the page. 4 is the coefficient here for b squared plus 6b. Also, another rule is to always put your exponents in descending order. The greatest exponent goes first. And we're going to work on that more throughout the chapter or throughout the book. All right, let's look for like terms here. I'm going to circle my like terms, 7a and negative 2a. Somebody might say, well, isn't that just a 2a? Yes, but that subtraction means it's a negative 2a, or you're adding a negative. So 7a minus 2a, I'm going to set those beside each other, plus 4 minus 6a squared. And that will allow me to say 7a minus 2a is 5a plus 4 minus 6a squared. And if you were listening, I don't have these in the proper order. I said to put them from the greatest power to the least power. And 4 doesn't have an a, so it's understood to be a power of 0. So this would be the proper way to write that final answer, but right now I'm just mostly concerned with you combining like terms. When we look at D, we have a c squared, a c, and then a number without c. So this one is already in simplest form. So it said in our instructions to write the word simplified if it is already in simplest form. All right, next it gives it to us in words to write an algebraic expression for this verbal expression, then simplify the indicated properties used. So let's take this verbal expression and see if we can make it into an algebraic expression. I hear 6 times, so there's 6, times means multiply, times what? The sum of x and y. So the sum of x and y looks like this. The sum of x and y increased, means plus, by 4 times the difference. The difference of what? Of 5x and y. Now a lot of students try to flip-flop those. The only time you have to worry about order being backwards is when there's the word than. There's no than. It just says the difference of 5x and y. Now be careful. It was 6 times, not x, but the sum of x and y. So that indicates parentheses, because if I only multiply times x, I have not multiplied times the sum. It was increased by 4 times the difference. So I have to again put parentheses because it's the difference. If I didn't put parentheses, I would only multiply 4 times 5, and I need to multiply 4 times the whole difference, the results of 5x minus y. So let's write this here more neatly so we can see exactly what's going on. Okay, so there is an algebraic expression for the verbal expression. But then it says to simplify doing these operations. So I'm going to distribute my 6. And I'm going to write down my plus sign from here. Now I'm going to distribute my 4. And now I'm going to look for like terms. I see an x and an x. I see a 6y and a negative 4y. So let's combine like terms. 6x plus 20x plus 6y minus 4y. So I have a total of 26 x's, and when I had 6 y's, I took 4 y's away. I have only 2 y's left, and that is as simplified as I can get this problem. So what is a coefficient? I mentioned a coefficient earlier. It's the number or the numerical factor of a term. That's the formal definition. The numerical factor of a term. You'll hear me say the number, this is in my words, in front of a variable. That is a coefficient. The numerical factor of a term. So here it says identify the coefficients. So 6 would be the coefficient here. This is understood to be 1x squared over 3. So 1/3 is our coefficient, and there's always an understood 1. I hope that that helps to refresh your memory about some basic algebra skills, and I hope you have a fantastic day.